Hello everyone, let me introduce easy guide to understand RecurDyn Contact. For efficient and accurate multibody dynamics simulation, contact is one of the crucial factors. In case of force and joint, they can be calculated based on physical laws. Unlike these cases, contact has many numerical terms. In fact, many people have difficulties in understanding contact. But for efficient, fast, and accurate simulation, it is very important to understand the basics of contact algorithm. This is the index of this seminar. First of all, I will introduce contact mechanics and the basics of RecurDyn Contact briefly. And I will introduce the types of RecurDyn Contact and some basic functionalities. After that, in part 2, I will explain the general process of contact modeling step by step. Finally, I will show some case studies to demonstrate how to determine the contact type and how to use the parameters. Contact is a primary factor of interaction between bodies in most mechanical systems. So, in the simulation of mechanical system, contact modeling is extremely important. What is important for contact? It is important to define the contact conditions in an easy way. And fast contact algorithm is important. Of course, the results must be accurate. And various and easy to use post-processing are important. Since both rigid and flexible bodies are often used together, contact between them must be supported, including self-contact for the flexible bodies. RecurDyn Contact provides convenient UI to define the contact conditions easily. To define contact is just a few clicks away. And RecurDyn Solver has very fast and accurate contact algorithm. Also, the various results of contact can be reviewed directly in RecurDyn's UI. For beginners, it is enough to use the basic functionalities of RecurDyn Contact. However, to be an expert of RecurDyn, it is needed to understand the basic contact algorithm and contact parameters. So, in this seminar, I'd like to explain some key points of RecurDyn Contact algorithm and usage of the parameters. This chapter is about mathematical contact algorithm. I believe most of you don't want to learn mathematics here, so I will talk about just key points and skim most of the formula. If you want to know more about the algorithm, please read this document by yourself and refer to the related papers. In fact, the analytical approach has had no big change since the first theory of contact mechanics. Similar to most of CA software contacts, RecurDyn contacts are based on Hertzian contact model. The key is that this Hertzian contact model uses penetration between two objects. I will explain this later again. Based on Hertzian contact model, RecurDyn uses this yellow formula. According to Hertzian contact model, you can calculate the stiffness K based on the radii of the spheres. The default value of RecurDyn contact stiffness is based on this value. Stiffness coefficient K of the contact based on Hertzian contact theory can be calculated using the material properties E and nu and radii of the curvature of the solids. So, you can calculate K using this formula. Function Bay provides a stiffness helper in Excel file to calculate K. You can input radii and material properties to automatically calculate K here. Now, Let me explain the basics of RecurDyn Contact. Please listen carefully. As will be introduced later, RecurDyn's contact can be divided as shown in this chart. First, it is divided into 3D contact and 2D contact. Then, 3D contact is divided into general contact and primitive contact. General contact is divided into Geosurface Contact and solid contact and legacy contact. 2D contact is divided into general contact and primitive contact. In most cases, you just need to use Geosurface Contact and primitive contact for 3D contact, and GeoCurve contact for 2D contact. Let me explain the computing process of RecurDyn contact first. First, the bodies get close. Since there is no penetration, the contact force is 0 yet. Second, there is a bounding buffer box around each body. It is a little bigger than the original body. This bounding buffer box is related to maximum step size factor. If these bounding buffer boxes overlap each other, RecurDyn solver judges that contact will occur soon. So, solver uses maximum step size factor. If 2 is used as maximum step size factor, the current solving step size is divided by 2. If 10 is used, the solving step size is reduced to 1/10. Third, contact occurs. Then, contact force is calculated using penetration. Fourth, the bodies are bounced off and separated. After that, bodies and the bounding buffer boxes are not overlapped anymore. So, the maximum step size factor is then used, and the contact force becomes 0 again. In this page, I'd like to explain what penetration is. Penetration is very important in contact calculation. Please see these bodies. In reality, the bodies are not overlapped, but contact algorithm assumes that they can be overlapped like this. Here, the amount of the overlap is called penetration or penetration depth. And RecurDyn Contact uses this penetration to calculate the contact force as below. Like this. In this formula, delta is the amount of the penetration. This is the basic contact force formula. If the damping force is included, the formula becomes like this. So, stiffness and damping coefficients in the contact parameter dialog are conceptually the same as stiffness damping coefficients in the spring dialog. Like this. This is the contact force dialog and this is the spring force dialog. In this example, the penetration increases until the external force and the contact force reach equilibrium. To make it simple, unit was ignored here, and 30 means the weight of the box. In case 1, the weight of the upper box applies force 30 downwards, but there is no contact force because delta equals 0, so the upper box moves downward. In case 2, there is penetration. Delta is equal 1, so contact force occurs. But since 30 is greater than 10, the box still moves downward. In case 3, 30 is still greater than 20. The box still moves downwards. In case 4, finally, the force equilibrium is achieved. 30 equals 30. Here, to help your understanding, it was explained as if delta is very big, but in reality, delta is very small. This is the basic formula of the normal force of the contact. Stiffness force is calculated based on Hertzian contact theory using penetration. This is the stiffness coefficient. Damping force is calculated based on a little more complex formula. like this. Please note that delta dot is the same as the velocity. There are two methods to calculate the damping force. One is boundary penetration method, the other one is indentation exponent method. But it is okay to use the boundary penetration, which is the default option. Usually, it is okay to use the default value for this rebound damping factor. But let me explain briefly what this is for. The direction of the damping force varies according to the relative velocity direction. The damping force direction is opposite to the moving direction, like this. So, during separation, this damping force can act like adhesion force, as if it is sticky. To reduce the adhesion effect, rebound damping factor can be used. Briefly speaking, the rebound damping factor makes the damping force smaller during separation. Well, friction is very tricky because it is discontinuous. For stable numerical analysis, friction coefficient needs to be expressed as a continuous function like this graph. To make the friction coefficient continuous, not only static and dynamic friction coefficient, but also the parameters called static and dynamic threshold velocities are used. Threshold velocity means the reference velocity to determine static and dynamic state. Conceptually, if the body moves slower than static threshold velocity, it is in static state. And if it moves faster than dynamic threshold velocity, then it is in dynamic state. To detect the collision between two bodies, the solver needs to check if the surfaces are overlapped or not. If the bodies are spheres, it is easy to check because we know the sphere equation. But for the 3D general surfaces, it is difficult to get the equation. So, RecurDyn divides the surface into small polygons to detect the collision. This small polygon is called facet or patch. In RecurDyn, it is possible to preview the size and shapes of the facets like this. The size and shape of the facet significantly affect the simulation performance. So, it is important to understand these parameters to use them efficiently. First, plane tolerance factor. This is one of the most frequently used parameters. There are differences between the curvature and the facet lines. It is kind of error. Smaller tolerance means smaller error is allowed. The smaller this value is, the more facets are generated, and the more accurate results are obtained in general. Max facet size factor limits the size of the facet. It means the smaller this value is, the more facets are generated. This parameter is often used for a flat surface or a cylindrical surface. Here is the demo video. For a sphere, you can see how plane tolerance factor works. 1 is used, then 3 is used, then 8 is used. For a cylinder, you can see that the facets are too long. If the plane tolerance factor is changed, the shape of the facets is affected, but they are still long. In this case, you can change max facet size factor. The cylinder surface is divided into small facets. Look at this. See? See? Especially in case of the flat surfaces on a box, plane tolerance factor has no effect. See, this is the plane tolerance factor, but no difference. In this case, you can use maximum facet size factor for the flat surface, like this. In this chapter, I will introduce the types of RecurDyn contact, especially 3D contact. Here, let me explain some details of 3D contact, especially about geosurface contact, solid contact, and primitive contact. First, solid contact. The basic algorithm of solid contact is that contact occurs at one point. So, solid contact is fast, but not appropriate for the contact between complex surfaces since there are many contact points. This contact only supports rigid and rigid contact. This is effective when penetration is relatively small or when the contact occurs between convex surfaces, or the contact occurs between convex surface and flat surface. Second, primitive contact. It is also called analytic contact. For primitive contact, mathematical equation of the geometry is used instead of the facets. So it is much faster and more accurate than general 3D contact. But general surface cannot use this analytic contact. As you can see, there are many kinds of primitive contacts in RecurDyn. It is very useful if you can use these primitive contacts appropriately. For example, this model uses sphere contacts, and it is 13 times faster than using general 3D contact. This model uses cylinder contact, and it is 7 times faster than using general 3D contact. Here is one tip about primitive contact. When CAD geometries are imported, sphere, box, and others are not recognized as primitive geometries in RecurDyn by default. So, you cannot use primitive contacts for them. This option, the convert primitive geometries when importing CAD files, must be checked before importing CAD files. Then, sphere, box, cylinder in CAD geometries can be recognized as they are in RecurDyn too, and primitive contact can be used for them. Let me introduce Geosurface Contact, which is often called GeoContact. This contact is recommended in most cases. If you need to use contact, please use Geosurface Contact first. Then, you can consider if you can use primitive contacts or solid contact instead. As you can see, if you use Geosurface Contact, the contact force distribution can be displayed like this. Geosurface Contact uses node contact and edge contact. And this contact supports not only rigid-rigid contact, but also flexible-rigid and flexible-flexible contact. Of course, both R-flex and full-flex bodies can use this geosurface contact. Also, this supports several advanced options and functionalities such as CPM, smooth option, and contact pressure. Like this. Please note that geosphere contact and geocylinder contact are partial primitive contacts based on geosurface contact. Geosurface contact algorithm uses node contact. Node means the vertices of each facet, like this. So the contact force is calculated at all nodes of the facet. By default, only node contact option for action geometry is checked, like this. This is for base, it is unchecked. You can use this default setting as it is in most cases. Edge here means the edges of each facet. The contact force is calculated when edges of two geometries meet. For example, let's see these two boxes with a small number of facets. The nodes only exist at the vertices of the boxes. So when two boxes contact, no node contact occurs because node doesn't penetrate the facet. But with this option, contact force can be calculated at the intersections of the edges. This option is checked by default, so you don't need to bother with finding this option to be checked. Since Geosurface Contact uses facets instead of the original surface, there are discontinuities at the nodes and the edges of the facet. This discontinuity can cause the oscillation of the contact force. If the smooth node contact option is used, RecurDyn solver generates harmonized surfaces from facets to remove discontinuity. As you can see, when this option is not used, the magnitude of the contact force is not smooth. You can see the direction and magnitude changes a lot. See? But with this option on, the contact force becomes very smooth. See? The contact force, the direction and magnitude changes very smoothly. Let me explain CPM, consistence penetration method. In most cases, users don't need to modify this option, CPM. CPM is used by default, but please remember when this option is needed. If this option is not used, the contact works as if the stiffness is increased in proportional to the number of contact points. For example, there are three cases like this. In case 1, there are two contact points, so contact force is calculated like this. So the penetration will become F over 2K. In case 2, the contact force is this. So the penetration becomes F over 3K. In case 3, the penetration becomes F over 5K. It means for the same model, penetration can be different depending on the number of contact points. In other words, the simulation results can be different depending on the number of contact points. To prevent this kind of differences, CPM is used by default. With this option, K, stiffness, is recalculated to be inversely proportional to the number of contact points. Please note that CPM is valid when the direction of the contact forces are uniform. If the contact direction is not uniform, such as a cylinder that fits tightly into a hole, CPM doesn't work properly. I will explain this case later. There are legacy 3D contacts. These contacts were developed a long time ago. They are just for the compatibility with the old RecurDyn models, so you don't need to use these legacy contacts. 2D contacts are often powerful option when the bodies have only 2D movement. GeoCurve contact is recommended in most cases. Since this is 2D, curve is divided into short segments, not facets. Parameters are similar to Geosurface Contact. There are 2D contacts such as primitive 2D contacts and legacy contacts. I have explained the wide range of information about contact. So let's review the summary so far before moving to the next chapter. First, RecurDyn Contact is based on Hertzian contact model. And this is the basic formula. And please remember that RecurDyn uses the penetration to calculate the contact force. Delta here is the penetration. And I explained the basic parameters for stiffness, damping, and friction. To represent the 3D shape of the geometry, RecurDyn uses facets, and it is important to understand the parameters for facets. For example, plane tolerance factor and max facet size factor. RecurDyn Contact can be divided into 3D contacts and 2D contacts. For 3D contact, I recommended Geosurface Contact for most cases. And I explained primitive contact and solid contact. For 2D contact, I just explained briefly about GeoCurve contact and primitive contact. Here are some basic technical tips for RecurDyn Contact. In fact, I already explained these tips during this seminar, but I think it will be helpful if you read these technical tips later. This is the end of part 1. Then please watch part 2. It's about general process of contact modeling and case studies. If you have any question about this seminar, please post your question on the forum of Function Bay Technical Support site here. Thank you.